Hello. Today we're actually going to talk about physics basic intro. So today in this video we're going to discuss about physics and its basic intro, the basic introduction to physics. And in the physics, in the second video, it'll actually go more different. Okay, so in my channel, I first go very easy to hard. So this is just an easy basic intro, so that there's nothing, right? Nothing to consider that hard, right? In this. So let's get started. So let's start out with our basic intro. So today we're actually going to just start up like arrows or some things, arrows, right? So we're going to talk about distance, displacement, velocity, speed, acceleration, net force, and projectile motion. So let's get started with distance first. So distance is, in the last video I answered like distance formula. That's only for math. Now if we want to use for physics, this is distance. Let's say if an object travels 12 meters east, 10 meters west, right? Then what's the distance? Remember, distance is always total positive, right? So it has to be 22. That's 22 meters, right? So that is the distance traveled, right? Now what is the displacement, right? Displacement, so like in display, so let's think of it this way, right? When you go west, right, it becomes a displacement, right? So when I was moving east, right, when I was moving east 12 meters, right, then that was the distance I was going. But since I was going left and here, if you want to talk about in the displacement matters, it has to be 2 because 12 minus 10 is 2. Well, why do we do 12 minus 10? Is actually to determine the displacement. The reason is because it travels the westward. Always remember this. When it goes east, then it's going positive, and when it's going west, then it's always going in the negative direction, right? Think of it just like the number 9, right? So we have showed you what is this displacement, right? Now we can talk about velocity, right? So how do you know velocity? So let's say if I have a ball, right? So let's just get started with it, right? Let's have a speed and velocity, right? So let's say if an object, right, goes 20 meters right, and 4 meters left, right, and it does that under 2 seconds, right? Then tell me the object speed and velocity. How do you do that? So remember, just like I showed you previously, distance is always positive, so it has to be 20 plus 4, right? Which is 24, right? And remember, if you want to determine the speed, right? Speed formula is distance over time. Since 20 plus 4 is 24, 24 over 2 is 12, right? The time is 2 seconds, so it has to be 2, right? So it's 24 over 12, right? It is, right? Now what about the velocity, right? So since it travels 4, right, westwards, then we can determine that the displacement is 20 minus 4, which is 16, right? And you do 16 divided by 2 because 2 is the time, and the speed. Since the speed formula is distance over time, the velocity formula is displacement over time. And since 25 minus 4 is 16, 16 is the displacement, right? So since velocity, average velocity equals the displacement over time, we can say that 16 divided by 2, which is 8, right? 8 meters per second squared, or 8 meters per second, or whatever, right? So that is one example here. Now we're actually going to talk about acceleration, right? So how do you talk about that? What do you do? So how do you talk about acceleration? So this is what let's say if an object, right, this object right here, right, travels 0 to 70, right, in just let's say 3 seconds, right? How do you determine the acceleration? So how do you do that? We do so like Vf minus Vo over T is the formula for acceleration, right? So what is the acceleration of this car? acceleration of this car is actually what's it called? Yes, 23.3 approximate, right? This is approximate, so let's just so it'll be like approximating 23.3, right? Meters per second square or meters per second, right? So that is how you determine the acceleration of the vehicle. What have I done? Sorry if I start talking for a while. It just happens. So now let's talk about what's it called? This, right? So what is VF, right? V final, right? When T is 0, right? VF becomes 20, right? The reason is because VO is 20. It's just a resting point. This is because it's 0 seconds and the initial velocity is actually 20, right? Since the acceleration is 8 meters per second square, right? 1, right? 1 second later, it will actually be probably like 28 meters per second, right? Square, or 28 meters per second, right? Or something like that. Might be wrong on this one, or whatever. So what about this, right? Minus 2 meters per second. That's the acceleration, 80 meters per second. So let's say this, right? So if the time, let's say if you move, like, let's say it's 80, right, at first, right, and what will happen 2 seconds later, right? It's actually minus 2 meters per second, right? So this means that so let's say like 80 minus 2 is 78, right? It'll be 78 meters. Well, that should be 78 meters per second, right? The object is just, I'll be like 80 meters per second, right? The object is traveling, right? The velocity, right? And it will be and it'll still be the what's it called? Yeah, it'll still be 80. No, I mean it'll still be 78 as speed too, since the absolute value of 78 is 70, right? Speed, the absolute value of velocity is speed, right? So yes. So let's talk about this, right? This is probably to do with like projectile motion and stuff, right? So let's say if I have a ball, right? It's actually v when Vy is this, right? So let's just determine this, right? So what will happen 1 second later, right? 1 second later, it will actually go at like 9.8 meters per 9.8, right? I think it'll be like negative 9.8, right? And this does this if like any number you multiply. Let's say so 1 second later, this will be negative 9.8 meters per second, right? Two in 2 seconds, what will this be? So this will be about like 19. I think it's like 19.6 meters per second, right? And at like 3 meter and like at what's it called, in 3 seconds, what will this be? So it will actually be what's it called? Yes. So what's it called? 30. What is it? 29. I think it's like 29.4 meters per second squared, right? So that is the part, right? So what about in the moon? So since the top one is about the Earth, right? E equals Earth, right? Earth is actually negative 9.8 meters per second, right? Well, as a Vy factor, right? And a Vy factor on Moon is negative 1.6, right? So 1 second later, it'll be negative 1.6, right? Now, let's say if I have a ball, right? There's 1, 2, 3, right? And then it goes like at 2 meters per second, right? And the t as 0, vx as 2, and vy, I think it's like 0, right? So what will happen to vx, right? So as you can see, vx always remains constant, I guess, right? So I think it's like 2 for all, right? As a vx factor, right? So there you get it, right? 1, 2, 3, right? Vx will always remain constant. Now vy on the other hand will not remain constant, so it will change, right? Right now I'm not really talking about that much of the physics right here, right? I'm just teaching you like normal stuff, right? That is not probably even needed, right? So let's say if I have a vx of 10, right? What will all the rest of the ball be? It will be just be 10, right? It will attract, and so this ball will be 99.8, and like times 2 times 3, right? And there's a 1, 2, 3, 4, right? There, right? So let's say this, right? Let's say if the ball has the initial velocity of negative 29.4 meters per second, right? How do you know when the ball will actually reach its gravitational potential height? So gravitational potential energy, right? Is actually negative 9.8 meters per second, right? And I think it's formula. I know the potential formula is mg8, right? So now I don't think we'll use this formula here, but I think we're gonna use it in like somewhere around this video or something, right? So as is, let's say if the person, right, holding this ball, as you can see, has an initial velocity of negative 29.4, right? Then what seconds would it take to reach its gravitational potential height? So the answer would be 3, because let's say, because like when let's say if you like when you subtract it 3 times, right? So let's say like a negative 29.4 minus 9.8, I mean plus 9.8 minus 9.8 plus 9.8. I think you do plus 9.8, or probably let's just say the velocity. Let's say the ball has initial velocity of 29.4, right? 29.4 minus 9.8 minus 9.8, right, would actually come actually in its zero state of form, right? And it will happen 3 seconds later, right? So in 3 seconds, right, the ball will reach its gravitational potential energy, right? Then it will go down, right? So that's how you just determine it, right? I'm not even really showing you that much, right? So let's talk about net force, right? This is to deal with, oh, sorry, my bad. So this is about like dealing with forces, right? So let's say if I have a ball. So remember, force is mass times acceleration, right? Right. So to put in more words, let's say if an object is traveling 8 meters per second, 8 meters per second, right? And let's just say, I think it's like probably like I'll just say 8 meters per second. Let's say if we do 250 newtons, right? Let's say if we have 250 newtons, right? And you pull the object 8 meters per second, right? It's going 8 meters per second, right? Then how do you determine the acceleration? How do you determine it? So force is actually associated with newtons, right? Since we have 250 newtons, right? Right? We know the mass. We don't know. Well, yeah, we already got the acceleration, right? Yes, I think we already got the acceleration. Now, what about the mass, right? So sorry if I said something else, right? So how do you determine the mass? So this is simple. Even if this is for acceleration or mass or whatever, right? You divide it by 8, divided by 8, right? And we get like so 3 2 point three and 2 is that 3 yeah 3.2 yeah 3.125 yeah 3.125 I think it's like 3.125 3.125 meters per second square, right? That's the mass, right? Let's just say if f1 is the acceleration, right? So how do you determine acceleration? Okay, so let's say if I have like the same 250 newtons, right? Let's just say that, right? And let's say if an object, right, this object, right, weighs 60, right? As the mass of 60, right? How do you determine the how do you determine the acceleration? So how do you do it? So let's do it in more like just like before. 250 60 a, right, divided by 60 divided by 60, and that should get you the answer, right? So I think it's like a determine. I mean, I think it's actually a repeated decimal, or even if it's not, it'd be like 4 point something, right? Yeah, 4 point. Yeah, just be like that. So that's how you determine the acceleration, right? Well, this is so easy. This is actually an algebra, right? Right, is determine the value of a, right? This is the same as algebra, saying that. So right now I'm only teaching easy stuff, right? In the next video I'm gonna teach about slope intercept and quadratic functions and stuff, right? Which is so easy, right? Nah, right? And then so in the next video or so, I'll do complex, right? More very very harder stuff, right? After my fifth, I mean after this video I'm gonna create a video which talks about very easy things, and after that it's done, right? I think I already talked about you with the projectile motion and net force, right? Alright, this is the last thing I taught you in the next force, right? Just remember F equals ma. Now have we determined force yet? So how do you do that? So to do that, you can just do mass times the acceleration. Let's say if an object weighs 10, right, and it's moving at 5 meters per second, right? Then or something, right? Then we'll get 50, right? 50 newtons, right? That's the answer. That 50 newtons, right? That is the force, right? An object, right, that is always in its potential state, right, only moves by a force, right? This is in Newton's laws, right? Now let's talk about a elastic potential energy, right? I don't remember the formula or something, but I remember this, right? So let's say if you like stretch a rubber band, right, by 200 newtons, right? I mean, let's just say if you like, so like, what force is needed to stretch a rubber band by, by like, um, I'm just like trying to like see like what I want to like see. I just want to show you hard stuffs. You might think it's so easy. So sorry, I can't determine one. Just erasing everything because like I'll finish this, right? So like, well, let's talk about this, right? I forgot about this, right? So let's talk about potential and kinetic energy, right? So let's say if I have an object, right, that is actually distant, right? Let's have a rock, right, in a cliff, right? rock in a cliff that is 10 meters from the ground that weighs the object of 10, right? So what is the potential energy? So the potential energy will be what's it called, 980, right? And if VY factor would be minus 980, right? But it's, or something like that, I don't know. But still, I'll say 980, right? The reason why it's 980 is because it's actually 980 joules. Is the reason is because P equals mgh, right? M means mass, and that is 10, and the height is already 10, and g is actually the gravitational force, right? Which is minus 9.8, or we can just say 9.8, right? Something like that, right? And there we already get our answer, right? Now what about kinetic, right? So what do we do with the kinetic energy? So let's say if an object is going, like, let's say it has the mass of let's say 20, right? And it's moving at the speed of 50 meters. Let's say an object which is 20 and is moving 50 meters per second square, right? That is actually necessary. That it could happen. Smaller objects could go very faster, right? So what do you do, right? So when k equals 1/2 mv square, right? K equals 1/2 mv square, right? So we already have it, right? We already have 1/2 times 20, right? Times 50, right? No, 50 square, right? Times 20 times 50 square, right? So 2500, right? Times 20, right? It'll be 2500 times 2 is actually what's it called, 5, it's actually 5000, right? 5000, 5000, right? It'll be 5000, since 20 times 50 will be 1000, right? 1000, 10,000, right? 2500 times 2 is actually 2500, 5000, 50,000, 50,000. So then we do 1/2 times 50,000, right? And I think we should get our answer there, right? 500, right? 5,000. So now this is all we need to do to just determine it, right? Oh, sorry. 50,000, right? 50,000 divided by 2, right? So it'll be 2500, right? It'll be very simple, right? 2500. Oh, no, 25,000. I'm sorry about that. So it's 25,000 joules, right? Dang, that's a lot. 25,000 joules. So this is enough for physics. Let me know if you have any questions, right? And so in the next video, it'll be very simple, easy. It's like basic pre-algebra and algebra stuffs, right? In the next video, and in the video after my next video will then have very complex, harder calculus or very advanced things, right? That I'm gonna teach you in the video after my next video, right? The next video will be very easy, right? And in the next video, it won't be that hard. But after my next video will be very hard, right? There'll be more harder things after my next video, right? So let me know if you have any questions. Bye. Have a nice day. See you.